Writing net ionic equations. So the first step for writing net ionic equations is to write the complete molecular equation, the states of matter, and balance. So let's start there. Iron 2 carbonate with hydrochloric acid. So that is iron 2 plus, and carbonate, I remember, is CO3 2 minus, and hydrochloric acid is H ion and chlorine anion. So putting those two together, iron carbonate, the 2's will cancel each other out, plus hydrochloric acid will make, therefore, remember that it's a double displacement, so the plus 2 and the minus 2 for carbonate, plus 1 and minus 1 for chlorine. Iron will form with the chlorine, the cation with the anion, and hydrogen will bond together with the carbonate to form HCO3 and iron 2 chloride. Now, if I write the states of matter, I know that carbonate is always insoluble with a few exceptions. Iron is not one of those exceptions, so this is a solid. Hydrochloric acid is a strong acid. This is aqueous. Carbonic acid is an acid, so I will write aqueous here. And then iron 2 chloride. Chlorine is usually always soluble. It has a few exceptions. Iron is not one of them, so this is also an aqueous salt. Now, the downfall here is that this is a gas evolution reaction. So determine what type of reaction you have here. Because if I didn't take a step back and think of what type of reaction I have, I would just stop. And then I could miss the fact if this was a gas evolution reaction if I had a step forward. So carbonate is a gas evolution reaction when it's reacting with a strong acid. Carbonic acid, this is an intermediate and it's very unstable and decomposes to form carbon dioxide and water. So your actual reaction would be H2O plus carbon dioxide plus iron 2 chloride. If you were to place solid iron 2 carbonate and then pour in hydrochloric acid, you would see bubbles form. Those bubbles come from the carbonic acid gas that's formed. So if we clean this up and just write it down here, you would see carbonate, iron 2 carbonate plus hydrochloric acid will make water plus carbon dioxide gas and iron 2 chloride aqueous salt. Whenever you have carbonate that is in an ionic compound reacting with an acid, it has to react with another acid, it will always form water, carbon dioxide, and iron, not iron specifically, but in this case it was iron 2 chloride, but always form the ionic compound being a salt because it's aqueous. Now we can balance because we have the appropriate reaction written. So I have 2 chlorines, so I needed 2 here. And now I have 2 chlorines. I have 1 iron. I have 1, 2, 3 oxygens, 2 hydrogens, and 1 carbon. And so I'm balanced. And now for the ionic equation, you split up everything that it's ions. Split all aqueous solutions, essentially, except for weak acids. So iron 2 carbonate is a salt, so that stays together in the ionic equation. Hydrochloric acid is a strong acid and 100% dissociates, so that will be split up. Water is a liquid. The molecules are attracted towards each other, so that stays together in the ionic reaction. Carbon dioxide gas, the molecules are all over the place. The gases escape, but it's not forming into ions. And then iron 2 chloride, that's an aqueous solution, that aqueous compound that splits up into ions in solution. So we split that up into iron 2 plus 2 chlorine minus. And now, cancel out spectators. So those ions that had nothing to do with the product that formed. If you look at the states of matter, we have the liquid and the gas that are of importance that formed from the reaction of iron 2 carbonate with hydrochloric acid. So a net ionic equation is basically the summary of what is actually happening. What actually had to do with forming water and carbon dioxide, the two important products in this overall reaction. Well, I see that the only spectator ion, the only ion that I see on both sides of the equation, are 2 chlorine ions. So I cross those out, and then you just write your net ionic. Iron carbonate plus 2 hydrogen ions makes water, and carbon dioxide gas, and iron 2 plus ion. And then you can see I have an iron on both sides, a carbon, 3 oxygens, 2 hydrogens. I'm completely balanced as well. So that same process follows along even when you don't have necessarily a gas evolving reaction. So looking at the next one, nickel 2 hydroxide S, it already tells you that it's solid without having to look at the solubility rules, reacts with nitric acid to yield a green solution. So writing that, nickel hydroxide plus nitric acid, this is an acid, it's strong, aqueous, will make, well, I know nickel is plus 2, hydroxide is minus 1, hydrogen is 1, and then nitrate is minus 1. So hydrogen and OH are going to come together to form H2O, which is a liquid. And then nickel and nitrate are going to form together. Nitrate is always soluble, has no exceptions. So we followed this by doing double displacement, but now when I look and determine what type of reaction I had a compound that would dissolve in solution and form hydroxide, which is a base, and a compound that would dissolve and form hydrogen ions in solution, which is an acid. So this was an acid-base reaction where then I should check and see, did I form water and ionic salt? And I did, so I did it correctly. Then to balance the reaction, let's see, 2 nitrates, so I put a 2 here. So now I have 2 nitrates on both sides. I have 2 hydrogens plus 4 hydrogens and an oxygen. So if I put another 2 here, I'm completely balanced. And then you write your ionic equation. Nickel 2 hydroxide is a solid that stays together. Nitric acid is a strong acid. Note that if this was a weak acid, it would stay as a molecule in the ionic equation because it only partially dissociates, and we have to resemble that. Here, this is a strong acid. It 100% dissociates. So 2 hydrogen ions plus 2 nitrates makes water, stays together. That is our molecule that's not split up into ions. And then we split up nickel 2 plus aqueous, and the 2 pertains to the nitrate here. There's 2 nitrate ions. So now again, you cancel out your spectators and you see I have 2 nitrates on both sides, and that's it. And then you're left with nickel hydroxide 2 plus 2 hydrogen ions. That makes water plus nickel 2 plus ion. And then double checking, nickel on both sides, 2 oxygens on both sides, 4 hydrogens on both sides. And then you're balanced. So it's always knowing To first write your reactants if it's written, making sure that you're writing your reactants in the correct form with the correct charges. Always the cation, then the anion. Then writing your products. Your products is that the cation of one will go to the anion of the other, and vice versa. Then writing your states of matter and balancing and determining what specific type of reaction you have. Sometimes if it's a gas evolution reaction, there's a further step, which is not as obvious if you just write the intermediate and keep going. Then, in another reaction, when you realize it's acid-base, you can always double check to make sure that in an acid-base reaction, you form water and an ionic salt that would decompose into solutions into its ions.